Welcome, everyone. Thank you for joining the webinar. My name is Charlene Huang. I have been working with VMware for over 9 years. I'm a database architect at VMware IT. I'm responsible for database performance tuning, capacity planning, high availability and disaster recovery architecture design for mission critical applications. Zagui, could you introduce yourself?
Sure. I'm so glad you're back, Charlene. For a while, I thought I lost everybody. My name is Zagui Wang. I'm Director of Cloud Infrastructure Operation at the VMware IT. I've been here for a dozen years now. My team actually runs the virtual infrastructure for VMware corporate IT side. So our SAP deployment actually runs on our infrastructure.
Great.
Welcome, everybody.
Here is today's agenda. We will first cover our SAP HANA journey, then discuss HANA architecture, including the high availability and disaster recovery option we used. Next, we will discuss some best practice we implemented. Finally, we will touch on the benefits and the key takeaways. We start our SAP HANA journey back in August 2015. At the time, we did a greenfield implementation. We went live with SAP HANA Financial in May 2016. Because we were new to HANA at that time, we only had 3 applications, MDG, GRC, BI, running on HANA. We did gain more confidence throughout the project, so we immediately started migration of the rest of the critical application to HANA. So in August 2016, we actually have 3 more applications running on HANA, which is ECC, PO, and Salmon. At the same time, we start EDW HANA project. The goal of this project is to implement real-time reporting using HANA platform. After 3 months, actually we are live, technical live with this new EDW HANA platform. In March 2017, we transformed over 5,000 reports and dashboards to this brand new platform. The users start using HANA to do their real-time reporting. Because HANA license is very expensive, so we decide to implement SAP archiving solution at the early stage. We went live with archiving in June 2018. After a few months, we actually start another new project, which is SAP BRIM. SAP BRIM is used to manage the SaaS order for VMware. This includes all life cycle events, such as creation, modification, and termination. And also the customer usage will come into SAP for rating and charging. In February 2019, we actually started S/4HANA upgrade in parallel with SAP BRIM project. In June 2019, we are live with the BRIM technical platform. Now we have 3 more applications running on HANA, which is CRM, CC, and CM. In August 2019, our S/4HANA went live. So from here, you can see most of our SAP projects actually complete in 3 to 9 months. When most companies probably take a double time to implement them. So some people may think, okay, maybe you guys didn't do much in this shorter period of time. So I just want to show you some of the stats we gather for SAP R1. That's our first SAP project, right? Phase 1. How much work we have done in 9 months, right? So from technical point of view, we deploy 450 VMs across 2 physical data centers. We actually run 1,700 test cases, and we develop over 150 reports, interface, and conversion enhancement forms and workflow. So in 9 months, we really achieved a lot. From business metric, we can see we actually conduct over 70 plus design workshop and trained over 600 users. And we also made 300 plus business design decisions and implement 134 bank payment types. So that's really lots of work in 9 months, right? This gives you a glance of overall SAP deployment at VMware, right? So there's a main enterprise application we use from SAP standpoint. We have this ECC, right? That's right now is S4 HANA. We have MDG, we have CRM, convergent charging, we have Fiori, and we're using Vertex for the sales tax calculations. We do use GRC for governance, risk, and compliance. And we also using PO, BODS, convergent charging, SLT for data integrations. OpenText is our archiving solution. We mentioned earlier, Salmon is, we do use Salmon a lot for monitoring. We also have a Charm running on top of Salmon, which is managed code migration across the landscape. We also have native HANA, the finance team running the report against this native HANA. And there is more. We also have this EDW HANA real-time reporting environment I mentioned earlier, right? This is a HANA scale-out cluster. We have 1 master node and 4 worker nodes. Each node, we have 2.8 terabytes memory and 96 virtual CPUs. And they have its own log and data file system, and the binary actually shared in NAS storage. And we have both real-time and a batch load to feed data to this HANA systems. This is more like a logical view of our data warehouse architecture. As you can see, HANA is really serving the hot and the warm data. And we have over actually 55 source systems, including ERP and CRM, text file, OLTP. We have many OLTP systems which feeds data to our EDW HANA, either using real-time or near real-time method. And on the top level, right, we also expose HANA data as service using the HANA Access Engine API. We also using SAP BobJ as main reporting tools for the users. And user also using the Tableau for the visualizations. And Zagwe, you want to talk about the backend infrastructure?
Sure. I mean, this slide definitely basically shows that when it comes to hardware, you have an option, right? As long as SAP certified hardware, you have a lot of choices. In our case, if you look at all 3 deployments from S4 HANA to EDW to BRIM, we've been changing our hardware as we go. Early on, we deploy on HP hardware, and then we deploy on Dell, and then we move on to VxRail using vSAN, as vSAN is certified by SAP and VMware to run SAP HANA. So it's a really quite a few options available to you, and based on your workload, it's important obviously you figure out what kind of sizing you need. In our case, we have 4-socket processors, 1.5 memory to start with, 1.5 TB memory to start with, and then all flash-based storage, right? It could be either SAN or it would be vSAN. So if you look at the right side, it's our last deployment. We deploy on vSAN. And it's a 5-node vSAN cluster, and those are on 2-socket based on our HANA requirement, and 1.5 terabyte memory, and we still have room to grow as well. In terms of networking, on the bottom line, you can see that we have 4 10 gigabit networking adapters, recently we also started to migrate to 25 gig. And you want to have enough network adapter so that your vMotion, your vSend, VM Chrono interface, they all have enough bandwidth so to provide you the the best optimal performance you will need for HANA. So that's the hardware side. Let me move on to the next slide. So I want to talk about DR. Disaster recovery is really an integral part of running infrastructure in any environment. And that is true as well for SAP. When we first started deploying SAP, we built DR as part of the project, right? So as Charlene was saying, it's a greenfield deployment, why not? So we use SRM. If you're familiar with SRM, it's a fairly simple process, almost one button click once you set it up, right? So let me go through the steps, in terms of what to do when you do a test or when there's a disaster. So step number one, you shut down the production VM. On the production side, let me just quickly give you, on the left side is our production environment, right? So as you can see, the production workload is running there. On the left side, on the right side is the DR environment. So when disaster hits or when you do the test, step number one, you want to shut down the VM, right? And then step number two, you go to SRM, you basically say, okay, let's initiate a failover to the production, to the DR environment. And once you do that, the SRM will orchestrate everything. So the VM and application will come up on the DR side. Once it's up, you obviously will need business users and actually IT application, IT application folks to join you and verify everything working, and application business folks to actually verify the workflow. And then step number 5, you can keep that environment running in the DR side for as long as you want. In our case, we do over the weekend, 24 hours run before we fail them back. And step number 6 is production failback to the original data center. So all this process looks, quite a few steps, a little bit daunting, but with SRM, it's really just one button click. However, SRM by design is disruptive, right? As you can see now, you will have to, in order to do a test, you have to shut down the production environment. And it can be time consuming, even though the operation side is simple, right? One button click, because time consuming because all this has to happen in order, for full workflow to complete. So over time, we started looking at other options. For example, how can we make it faster by combining application level failover with SRM failover? So we're going to offer you a hybrid approach, and I think Charlene can cover the next slide. From a logical point of view, how do we actually do the DR recovery for SAP nowadays?
Okay, great. Thank you, Zachary. As Zachary mentioned earlier, SRM works really well for DR solution. Actually, in beginning of the SAP journey, right? We were happy with the SRM solution because it's so simple. Just a few clicks, everything is set up. And even the failover process seems very simple. You do click and the failover, right? So looks fantastic for us. The only thing is we got another business requirement because it's disruptive and take about a 2 and 3 hour downtime to fail over to the DR side, then take another 2 to 3 hours to fail back to the primary side. And the business says, oh, that's because we are doing quarterly testing, the business says, okay, that's too much. You guys need to cut down the downtime. RTO has to be less than 1 hour. That's what we are thinking, okay? How can we achieve these less than 1 hour? Because if you have so many VMs, you have using SRM solution, you have to really shut down and bring up everything, right? So for example, the HANA you bring up does take some time, right? So that's the thing we are thinking, okay, what we can do to reduce the RTO value? That's what we come up with, this application DR combined with SRM, right? So for most of the business critical application, we try to combine SRM with application level DR so we can reduce RTO. Here, just show you what we do in terms of application level DR, right? On the top, we can already see for the HANA, we're using HANA system replication. We do sync mode in the same data center to protect the HANA so we can have the HA, right? For the remote data center, again, we're using HANA system replication, but we're using async mode, so we have a DR side, the secondary running. And in the SAP application, there's one single point of failure, right? That's a ASCS or SCS component. We're still using VMFT to protect it in same data center. And then in the remote data center, we're actually using SRM to bring the DR instance over there. And for rest of the application like a PaaS AAS, what we do is we install same set of application server in the DR side. During the normal time, we actually keep those application servers down. Only they will start up when the DR happen, right? So then on the top layer, we also have a load balancer. We have a GTM. So GTM is intelligent enough to identify which side is up. They're going to route the traffic to whatever side is up. So this is the architecture we really help to reduce ITO to from 2 to 3 hours to 1 hour, right? But there's certain component which cannot using this kind of approach. For example, solution manager, BODS, right? You cannot really have installed another set over there when the database fail over. So then they will automatically recognize. Actually, it's not possible. For Salman, we contact with SAP, right? They say if you're using HANA system replication, your server node change, your Salman will break. You have to really do fresh again. So that's why we're still using SRM to protect, right? So really depends on application by application basis. The traditional SAP application, for example, the CRM, ECC, we all can use this approach. As I mentioned earlier, right? So we do the DR testing in production every quarter, right? So what we do is we let it run after we fail over to the DR side, we let it run for 20 hours. Then we switch back. We actually run in the production load in DR side to make sure everything is working, right? So then we fail back to the primary side. And actually, we also using this window to perform some OS maintenance on primary side. As I mentioned earlier, we do have these hybrid mode, right? For those application level DR, we can, apply the OS patch, and sometimes even the SAP kernel patch. We can do those things when the DR is running, when the application is running in the DR side. And we have been doing this kind of testing for almost 4 years. And one of the most significant benefit of this testing really is continuous improvement and validation. By testing every quarter, we actually can make an adjustment to optimize the operation process and capacity planning. So these kind of testing really make sure our support team become very familiar with the DR procedure, and they're prepared to quickly address when the real DR happen, right? So next 2 slides really talk about some like day 2 operation, right? We do use Networker to back up our databases. We use Avama to back up our application servers. We also do these schedule patching, like including ESXi host patching, OS patching, and kernel patching, right? And we do the application upgrade, database upgrade per requirement, and when there's a need to upgrade, we do so as well. Because SAP is in SOC scope, so we have to do the password change every 6 months. We also have this pre-production environment, which is same spec as the production. So every time there's any major change, we actually run the load test, like one times QE means quarter end load. We do 2 hours, and 2 times QE, 2 times quarter end load for 2 hours, and the longevity for 72 hours. We just want to make sure any change moved to production is tested. There's no negative impact to our production workload. We're using various tools to monitor SAP applications. VR ops, we normally using the server metrics. For example, if server up and down, CPU memory, swap usage, file system usage, we're using that. It works really well. And we also have variety of database native tool to monitor database. And for example, for the SAP HANA, you have this cockpit, right? Then for Oracle database, you have Oracle Grid Control to monitor it. And for the application-wise, we do use Salmon to monitor end-to-end SAP application, including some database, HANA database. We also using Salmon to send out the alert. Next, I will transition to Zagui to talk about some best practice we implement.
Thank you, Charlene. Yeah, best practices really are about optimization, right? Charlene mentioned optimization. We got every opportunity to optimize this environment. So I want to focus on 3 areas of optimization. From the lowest layer you can go is hardware side, right? BIOS setting. And in our environment, we do use high performance power profile so that your CPU will never get throttled, right? A few pennies saved is not worth it in this case, right? And the other couple of things I mentioned in here, actually, I think are default nowadays. Hyper-threading, enabling that, hardware assist virtualization features, all this, unless you explicitly disable them, they should be there. So just leave them there. In terms of networking and the storage settings, I think in here I mixed both VM layer and vSphere layer together. On the network side, you want to make sure you always use VMX Net3 network adapter, because that's the adapter designed to produce high performance and also feature rich as well. Now, Jumbo frame is something that we are religiously using in our environment, especially in network flow where you can control end-to-end, for example, vMotion, and other internal network, for example, HANA intranode network, or Oracle Red Cluster heartbeating network. So anytime you can control the end-to-end communication, and that's where you should use Jumbo frame to boost your throughput. Now we talk about vMotion. Now in our environment, we actually also use multiple VM kernel interface to do parallel vMotion streams, so that you have a much higher aggregate of vMotion transportation, right, from one host to another. Now, that means faster vMotion and much less application impact. The other thing I noticed that over time is that people tend to think, network side is always solid, something you can set up and forget. And we learned the hard way. It's not true. Anytime you change your network, any way you change it, right? Firmware, drivers, switches, hardware, firmware updates, they could also bring some impact to your network performance. So always monitor. And network packet drop is never good. If you have drops, you want to make sure you get rid of that by doing firmware updates, driver updates, and consult VMware compatibility guide and make sure that you are in compliance. Storage setting side, we always use multiple pair virtualized SCSI controller on the VM, because there's no point to just overload one controllers. And if you're using storage array, in general, the array provider will provide recommendation in terms of the host setting as well. For example, from EMC point of view, they actually have very detailed guideline on how you can tune the device queue depth. Device queue depth is very important. If you have very, very short queue depth, you're gonna have very poor performance. And the other parameter we tune as well is outsetting IOs, right? That parameter basically controls what's the preference you want to give to a specific VM, right? You want the VM to do a lot of I/O before it switches over, or you want to do frequent switching. So look at all these parameters by consulting the vendor's recommendation. UUID for the VM case, this is not a performance impacting thing, but this will make your operation so much easier because you can now uniquely identify a VMDK from the virtualization layer to a SD device within the OS. So that's something we always use. And if you do snapshot a lot, right, for patching, for quick backup, snapshot is not a backup, but people sometimes do a quick backup just to verify something's working before they delete it. You want to make sure you set independent disk mode so that the huge application and database VMDKs will not be included. Now, a new feature is coming actually. You can change the disk mode on the fly and with API. So in the future, in the very near future, well, I say this with a disclaimer. So we are not committing to anything, obviously. In the future, you can actually do this on the fly. So if you needed to back up a DB with a snapshot, and you can do that too by quickly switching from independent mode to dependent mode. Now, if you need disk sharing, do not use bus sharing feature. Instead, use a memory writer, because bus sharing will give you a lot of trouble, including disable the VM mobility. You cannot move the VM anymore. So those are the basic. I would almost say that those common sense, guidelines you want to follow. There are a lot of things, obviously, you can do to maintain a robust environment. VMware has a lot of documentation, and things such as NUMA, right? I didn't mention here. You want to make sure that you observe a NUMA physical CPU boundary as well. And so read the documentation is where I always start. Every newer release has newer guidance and better features. Read and understand them so that you can run the environment and per the best practices. So that's pretty much what I talk about. Now, the technical benefits, and I want to highlight a few things here. Right? Why do you run HANA on vSphere? First is the scalability. If you look at vSphere 6.7, or even in version 7.0, we can actually scale VM resource to 256 virtual CPU and 6 terabyte of memory. And that's huge, right? So for a lot of environment, this is more than enough. Charlene mentioned that in our environment, we actually only do 96 CPU, and we started with 1.5 terabytes of memory, and now it's less than 3 terabytes. So this is a huge room for you to run almost any workload. And by using fault tolerant, we mentioned we use that as well, HA and DRS, vSphere give you high availability, and no other product can actually provide this kind of high availability. And by combining that with monitoring tool, you can catch anything, and a recovery is almost automatic. So you really reduce the downtime to any application you're running in this environment. I talked about DR earlier. We were able to build DR from day one when we deploy SAP because the SRM feature, right? One button click, everything automated. With a newer release of 8.3 SRM, and now we actually offer automatic protection as well for all the VMs that sits on that protected device. Nowadays, SRM protection is automatic. So all this save a lot of overhead in terms of operational, life cycle management of your environment. and combined with application layer, database layer replication technology, and you can really produce something that's robust and quicker recovery, as Charlie mentioned earlier. So simplify operation. I just want to call out Workspace ONE product. We use that as a single sign-on for all our developers and business users. And the sign-on process is seamless, right? Nobody has to do multiple sign-on. We also make it even better by providing Horizon client, VDI client, and there was a pre-built, template with SAP tools built in. So user log into VDI client, and they have everything they need. And we're doing all this convenience, not really sacrificing any security features, because we use micro segmentation and SS-based micro segmentation in our environment to secure every application. So those are the highlights.
Okay, so in the last 4 years of running SAP HANA in production, we actually encounter multiple challenges, but all the challenge mainly is on EDW HANA platform because it's very complex. And for example, there's a smart data integration, SDI, which is part of HANA delivery service. We use that to perform real-time replication from Oracle to HANA and HANA to HANA. However, if the source system is Oracle, SDI can only process less than 1 terabyte archive log in 1 day. Plus, we can only use a single thread. In this limitation, because of this limitation, we actually cannot using this technology for certain Oracle source. For example, our current Oracle EBS environment, we generate actually more than 1 terabyte archive log per day, then we cannot use that. And we also encounter some bugs in the HANA scale when using SDI. Whenever we bounce target EDW HANA system, we actually receive lots of unique constraint errors, right? So ends up we have to reset all the replication and start over. So it took actually SAP 1.5 years to fix it because their original design, they didn't really test extensively in scale or the environment. In this EDW environment, we also provide ad hoc reporting to the users, right? So because that, and what we encounter is just one user can bring down the HANA completely with one bad queries. So now you see how ad hoc query impact to the HANA, right? So ends up we really have to limit the statement memory to 155 GB and threshold to 60% to control users' resource. We also, another lesson learned, we said the master node resource actually is very critical. See, if the master node is overloaded, user cannot even connect to HANA. So in order to mitigate this issue, we actually limit the number of tables in the master node. We actually place most of the tables in the worker nodes instead. Initially, some people thought that HANA is an in-memory database, so code tuning is not very important anymore. But in reality, tuning is still very crucial for HANA performance. HANA data modeling actually is the key to good performance in the long run. If you do not design the model correctly, you're going to encounter lots of performance issues. The size of HANA database, actually, it depends on the size of your data, right? So basically, the memory will be 2 times of your data. If you have 1 terabyte data, you will need a 2 terabytes memory. Because the HANA license is so expensive, so that's why it would be a good idea to implement archiving strategy at an early stage, so you don't overgrow your HANA databases. Another consideration is when to use HANA. For us, we only using HANA for critical application that requires very high performance. See, if your database database size is very small and the performance is not top concern. You can pick any open source database such as MySQL or Postgres, which is much, much cheaper, right? 1 second. Okay, I think I'm going to transition Zagui to talk about other considerations.
Yeah, thank you, Charlie. Yeah, so this slide really just a call out of something we mentioned briefly previously in the previous slides already. So 3 things I want to mention. Now the configuration maximum, right? We said it's really a scalability benefit. At the same time, I realized that for some HANA database, they may need more than 6 terabytes, right? So in that case, I think there may be ways to optimize that, right? Break it up, as Charlene was saying, make sure that you do archiving and make sure you be selective in terms of deploying stuff to HANA database. And these numbers actually are still true in vSphere 7.0, right? The maximum numbers. For majority of the customer, I think this is enough. Now, the second one I mentioned is vMotion. So I label this as a challenge, right? Anytime you deploy a VM with so many CPUs and so much memory, it's always offers some challenge. That's why we call that monster VMs, right? There is a reason we call that monster VMs. One of the challenges being vMotion can be slow because there are just so much memory, footprint to transfer over, especially if your application is very active. And the longer vMotion cutover time means, potentially performance impact as well. So in our environment, one of the workaround we enabled, I recommended as well earlier, is try to use multiple VM kernel interface to achieve higher aggregate vMotion bandwidth. So that way you can reduce the impact vMotion has to your application. Now, inside information, right? Because we are also, our product team is also improving vMotion performance, as you have seen over time, right? It's getting better and better. The third area I want to cover is HANA database can be very dynamic and can be very fast in growth, right? Even if you do archiving, even if you control, what kind of application to onboard to HANA, you could also still see real fast growth. We started our hardware with 1.5 terabyte of memory. Now we are at 3 terabytes, a few years into this HANA journey. So it's important to plan for growth in advance. And it's also important, don't max out your hardware. Leave some room. It's much easier to explain, to your CIO if you have to just expand your memory slot instead of repurchase hardware 2 years, 3 years down the road, because typically hardware depreciation schedule is 5-6 years, right? So plan ahead and make sure that you really take into consideration of HANA and its growth. Charlie, you can cover this one.
Yeah, as I mentioned at the beginning, all of our SAP project will complete in 3 to 9 months, which is much faster than expected. The key reason, actually, we are using VMware technology. This diagram just gives you some comparison of SAP project implementation between VMware technology and traditional technology, right? As you can see, we save about 50% time for almost every project. I think next Zagui will discuss in detail how VMware technology can save so much time. Zagui, it's yours.
Yeah. Yeah, I mean, we've been doing virtualization for so long. I can't even imagine how to go back and do this kind of work in the physical world, right? Let me just look through the list. Server provisioning nowadays for us is really just a matter of cloning from template. You can automate that as well. So installing or deploying 450 VMs, Charlene, nowadays is it won't take as long, as much time anymore, right? But imagine doing that to physical servers. Disaster recovery, we talk about the one button click. Right? I mean, it's almost a one button click, but just consider that if you do that in a physical world, how would you do that? So time saving is tremendous in our case, I think. The testing, I think we briefly mentioned the bubble. There was actually a question earlier asking about how we use NSX, right? Whether we use NSX for microsegmentation or we use NSX for virtual networking, and we use NSX for both. So on the security side, as I mentioned, we actually microsegment everything with NSX, and on the DR side, we build a network bubble using NSX virtual networking. So all that, imagine if you try to do that in physical environment. And the patching, it's update and patching. How do you maintain your environment always fresh and updated? And VM cloning obviously is one way to do that, right? If you can just, all you need to do is just update your template. So for any new deployment, you just do the deploy from the template. Now, fault tolerance is one of the key features we use to protect those single point of failures for ASCS and ACS. And the alternative is not pretty at all, right? If you imagine if you have to protect those components without FT, what do? You're going to probably have to set up a cluster, and maintaining a cluster is very complex, and it's prone to problem failure as well. And I think we talk about cloning quite a bit in here, and clone is just when we have quick provisioning, and we benefit so much from it. So vMotion, right? So in a virtualized environment, we can maintain and do updates of ESX host without ever cause any disruption to our workload. And literally, our user wouldn't even know we are doing ESX updates and vSphere updates. So if there is a hardware failure, our HA will take over, and the VM will have a brief disruption and go back to resume operation. So it's all that benefits is only in virtualized environment you can get. So as I said, I haven't touched physical environment for so long, and I can't imagine how to do it now. All right, let's see the next slide. So this slide gives you some idea about what is VMware on VMware. It's a corporate IT initiative where we try to share our knowledge with our customers. And we also actually, during the course of doing that, we also learn, what the challenges our customers are facing nowadays. So there are some information here. You can email VMware on VMware if you have questions. You can follow the VMware on VMware blogs. And there were some videos and past presentations you can find on the URL. And VMware on VMware has a Twitter account as well, so make sure you follow that Twitter. And we do webinars like this very often. So these are the listing of in May and June, the choice you have. And if any of those topics actually interest you, feel free to sign up and enjoy. And I think we have more. Yeah, June and July. So, and these are these keep coming. So just check back, and there is a URL on the bottom of this page to show you where you can check back and get updates. So I think that's the end of this presentation, and we're open for question and answers. as I said, there is a question earlier regarding how we use NSX. So I answered that already in the text box. There is another question. Let me see, Charlene, if this is your question. Yeah, so this is a question regarding a NAS replication, and how does that fit with your use of vSAN now? The structured cluster, or how do you replicate the data? So we don't use structured cluster for the SAP deployment, and Charlene, we still use NAS, right? For the data and the binary, I think. Earlier you mentioned that.
Well, we're still using that, but we expose that vSAN as kind of like a NAS share, and then we still do the replication underneath.
Okay, so this is more along the line of NFS as a service on vSAN. Sounds like, because otherwise we can just also use the vSAN NAS storage array as well, right? We're still using that. Mm-hmm. And the storage array typically come with the replication solutions.
Mm-hmm. Yeah.
Okay, and there's another question, Charlene. I think this you can answer. Is there any overhead running SAP HANA on vSphere?
Okay, so we never run HANA on the physical machine, so I cannot give you a comparison, exactly apple-to-apple comparison. But I want to share a story. When I joined more than 9 years ago, and we used to run Oracle RAC on the physical server. One of my first initiative is run the RAC environment in the vSphere environment. So we did an extensive study, right? So we did a comparison side by side, and we run the load on the physical server. Then we again run the load on the virtual server. We basically don't see much overhead at all. We achieve similar performance as running on the physical servers. And I would say, you will see almost no impact these days. Probably very old days, you see slight performance impact. I would say like back 10 years ago, I would say you see like less than 5%. But nowadays, as the technology evolve, we do not even see some overhead right now.
Yeah, I mean, with the technology evolves, with the CPUs getting so much faster, we get so much memory speed is going up. The overhead, if any, is almost negligible nowadays. And I think the benefits is compelling, right? It really outweighs any overhead you can think of, as I mentioned earlier. So it's all the benefits are really just something that completely outweigh that consideration. So the other question, let me see, let me look it up.
Yeah, I can, I found one question maybe for you. What is the size limitation to use FT?
Oh, so this FT sizing has been changing over, a version of vSphere. I think initially it was very small. Nowadays at 6.7, in vSphere 6.7, you actually can deploy a VM and FT protected with 8 CPU, 128 gig of memory. That's very sizable. That's I mean, compared to what we have in our environment, right? I think we have 2 CPU and 8 gig of memory.
Yeah.
So yeah, you do have a lot of room to grow if you have the FT protected VMs.
Yeah, there's another question for you as well. How do you handle file system resizing without a downtime?
So I'm more familiar with the Linux. I think on Windows side is probably automatic nowadays. On the Linux side, we use LVM as a middle layer, right? So with the LVM, you can build your volume group, build a PV, and you can enlarge your LV very easily. And growing the file system itself is just a normal operation within Linux environment. So using a logic layer is very important, and we do that in our environment.
Okay, great. Oh, Zachary, I remember the previous person asking about the vSAN, you know, the NAS one. I remember we actually using the Unity, remember?
Yes, Unity virtual appliance, that's from
Yeah,
VMC. Yeah, we deploy that on vSAN, and then we use that as a an FS server.
Yeah, so that's what we are using for the SAP on vSAN, right? We have HANA running on vSAN. We're using that,
Yeah.
you know, use that. And also for the SAP application, there's NetShare. We're also using that, so we can replicate data to the DR side. Actually, for SAP Brim, we actually have the DR in the VMC, the cloud in Amazon. Right?
It's a VMware Cloud in AWS. Yeah.
Yes, that's
the
correct.
official name for that.
Yeah. And also like this one question, I think you probably already answered that regarding the NUMA. Say, how do you consider that when you do the CPU assignment? I believe you
I briefly mentioned NUMA. It's important, I want to point out, it's important to really align your CPU assignment with your physical topology. For example, if your physical machine, your ESX host has 2 CPU sockets and 18 cores, and on the VM side, you typically would assign, you know, 1 socket and as many cores as you need until you reach 18, and then you start from 2 socket, right? For example, if you need 24 cores on the VM and your physical machine has 18 cores per socket, you would do 2 by 12, right? If you require 16 cores, you would do on the VM layer 1 by 16, meaning 1 socket 16 virtual CPU. So that's the NUMA boundary we try to observe. And there is a VMware blog on that as well by Mark. So I encourage everybody to look it up and use that as a good reference.
Any more questions? You can type in the Q&A box so we can answer them.
Yeah, we got 3 minutes to go.
Yeah.
Charlene, one question is about the standby.
Okay.
In your diagram, I don't think we showed any HANA standby, right? The question is why.
Okay, so basically in VMware, we do not using HANA standby. We actually using VMHA to protect it. And basically, initially when we do the scale out, we try to using the standby mode, using the storage adapter, all the stuff. And we figure out actually it just increase more complexity. So it's we finally assess the pro and cons. We decided just using VMHA to protect it. The landscape will be simplified. I think there's one question. You talk about the cloning for OS patching. Can you expand on that? So basically, this question, I think I can answer one part of. Maybe Zachary, you can add on that. Right?
I think there is some confusion on that, I guess, right? Maybe I misspoke on that. So yeah, OS patching, strictly speaking, you cannot use clone to do OS patching. I think what my point was, if you have a way of saying, deploy a VM on the fly to do any in-place upgrade or whatever, right? That's when you can do the cloning, right? But typically for the normal patching activities, life cycle management, you cannot just clone the VM and bring it in unless you have a good configuration management. In our environment, we do use Puppet. So for some application, we are able to achieve that. For example, if instead of doing in-place upgrade or patching, we can simply deploy a new VM and cut it over and remove the old VM. So that's doable. But for majority of the patching, it's not OS cloning. It's automated patching using OS tools for example, Yum, if you're using CentOS and Red Hat. So it's a mix of both, I guess.
Yeah, actually for us, really, I always say this one scenario apply is before when we doing like new project implementation, right? Sometimes there is additional OS patch required. They actually patch in the template. So next environment, we just clone from template. We don't have to, install this OS patching again, right? So that's for new provisioning, right? So we just do the cloning. And even for the application patching, same thing. Initially, when we did a project, we have all the patch apply in one of the VM template, right? They actually save that template. So what we do is every time we need a server, we just deploy a new one from the template. That template actually already have application binary, everything installed, and including the application patches, right? We just need to rename and get everything up running as a new instance. So that's why
the key is you need to have a good configuration management tool so that your existing configuration in your existing environment will be retained when you do that, right?
Yeah.
Yeah. So that's the catch.
Yeah.
I think we are out of